Under the certain conditions, suppose their temperature change or any other their conditions are there, different conditions, the number of atoms of some elements give away or take up different valence electrons. Suppose we'll take the example of copper. So in copper you will get there first symbol is there Cu, and when it will be there, it shows valency 2 type, that is a valency 1 and valency 2. Where copper plus it reacts in the certain condition, that time it's gives there plus 1. That means that is valency shows there 1. It's called a cuprous. It's called the cuprous. And about the when it shows valency 2, a certain condition is there, different types of condition or different types of reactions depends on it. It shows their cupric. When we have to require their, suppose it's going to form their cupric oxides, that time it shows that valency 2. About the mercury also, it can show the valency 1 and 2. It is the variable according to the condition, according to the reaction it will show. So first when there it gets the mercury, at that time it shows the valency 1. There H plus 1 plus means their valency is 1, and when there 2 plus, that time it shows the valency 2. It gives the 2 electrons. Okay. About the iron Fe, ferrous. So when it shows valency 2, that time its work as a, or its name is the ferrous, and when it's valency 3, that time it's called ferric. Okay. So there is always remember one thing, iron Fe exhibits valency, variable valency between 2 and 3. Therefore iron forms 2 compounds with chlorine FeCl2, and with 3 chlorine, that time FeCl3. Okay. Now research, this is given for you. Can you do it? Research for you. So you have to do it, find out some more elements which have variable valency, and find out compounds of the above elements which have the variable valency. Now here we have to learn this radicals. Before that we are going to complete this chart. Here given NaOH. So NaOH. So which type of cation is here present? Na plus. Na plus. Then anion, which is the anion is here? OH minus. So already we have spoken about it. OH minus. Now here also KOH. Here it shows the plus K and OH minus. About CaOH2 also will get the same, in sodium hydroxide, potassium hydroxide, and calcium hydroxide. About these acids, this is where the bases. So here we got their H plus and Cl minus. But when we are going to speak about the acids, we will get here H plus cation, and here we will get the Cl minus. About here, you get everywhere H plus cation, and Br is the anion here. H plus it will be cation, and NO3 it will be show the anion. So from this we are getting that every compound which is ionic compound, we are going to speak about the ionic compound. It is made up of 2 different ions. Ionic compounds, their combination of 2 ions. Combination of 2 ions is called the ionic compounds. Okay. So already what is my compound? You know very well compound definition. Okay. When 2 or more than 2 substances combine together, they form a new substance with new physical and chemical properties. It is called the compound. And here when 2 or more than 2 ions combines together and they form neutral or form a new product, it's called ionic compounds. Okay. And which types of ions are there present? One is the positive ion and second one is the negative ion. Got it everyone? Yes or no? Any problem here?
Yes, sir.
Anybody?
Yes, sir.
Now here we have to see radicals. What is meant by radicals? So those ions are taking part in the chemical reaction independently. Suppose this positive and negative ion both are taking part in reaction, but they are taking independently. Positive ion is separately and negative part is separately. They are not dependent on anyone. These are called the radicals. These ions are called radicals. So we are getting there 2 types of radicals, that is acidic radicals, and second one is their basic radicals. Okay. So here's the example is given in the chart, that is the KOH, NOH. So it will be there if we'll see are formed when the various cationic radicals, which type of cationic radicals, and they are paired with the different anionic radicals, and these radicals are called basic radicals. When we are going to speak about this NaOH and KaOH, they are called basic radicals, and about HCl, then it gives the H plus, and these H plus ions, these cationic radicals, it's called the acidic radicals. Got it, everyone? Yes or no?
Yes, sir.
Any problem, anyone front? Now we know that we are writing Na plus OH minus. Suppose Na plus Cl minus. We are writing these chemical formulas. But how it forms? Well, two ions combine together, they form a new substance. We know that they form the ionic compounds. So those cation and anion, that is a basic radical and acidic radical. So these two parts are oppositely charged and they always attract towards each other. We know about this. Positive and negative charge. Opposite charges always attract towards each other. So here happening same thing. When their positive and negative charge are always attract towards each other and they form a new substance. That's called the ionic compound. And between that Na plus and Cl minus, suppose positive and negative charge, there is attraction between it. That bond is called the ionic bond. That bond is called the ionic bond. And then we have to write their answer in ionic compound there. Two words. First word is the name of the cation and second is the name of the anion. When we are going to speak sodium hydroxide. Now see, I am writing sodium hydroxide. So this is the first word of the sodium. The second one there, Conan leaves, we call it. Okay. When these two, their positive ion and negative ion, when they combine, they form the ion compound and they show their ionic bond between it. That time, when we have to give its name, first we have to decide the first sodium. Suppose sodium hydroxide here, acidic and basic you can take first acidic and then after basic, or first we have to take the positive ion and next second one we have to take the negative ion, then we will get it. Okay, so symbols we know very well how to write symbols. Na plus is a here like this. Suppose I am going to write Na plus Cl minus, Na plus Cl minus. So this is a when both are combining together, then we are writing just like this NaCl. Getting it, everyone? Yes or no? So like this, we can write the symbol of it. Now we have to see the next thing. That is a very simple. How to write their molecular formula. That is very important thing. Molecular formula. Step first to write the symbols of the given radicals. Suppose now we are going to speak about the sodium sulfate. What is it? Sodium sulfate. Now, what is first radical? Sodium. Basic radical written on the left. Remember this. Basic radical here written on the left. Then this acidic radical SO4 we have written here like this. Now, while to writing the valency below it, that time we have to decide their respective radical. Suppose now sodium there, how much? Na plus means 1 and SO4. So we know that it is a 2. Okay. And then we have to do its cross multiplication. What we have to do? Cross multiplication. Then what will we get? Na2 and SO4. Only single we have to write, not double there. Getting it? It's valency. We have to consider its valency here, then only we can write it. Suppose now you'll get here Na2SO4, but here SO4 means this is your sulfate. Okay, this is your sulfate. But here valency of this sulfur dioxide, here we are getting its valency is 2. Okay, and here valency is only 1. So we have to just change their valency and we have to write like this Na2SO4, and this will get the molecular or chemical formula of this given compound. Now we are going to write different their chemical formulas on it. Okay, so now suppose we have taken the sodium, its valency is 1. Okay, Cl, its valency is -1. So we can here 1 1. If we do cross multiplication, nothing happen, we'll get directly NaCl. Getting it? So like this we can do it and we'll get our answers. Understood? Or any problems here? Students, any problem in this simple formula?
No, sir.
No, sir.